Dependency injection gone wrong can cripple your codebase. Dependency injection is a technique to supply dependencies from outside a class to improve modularity and testability. Developers use it to reduce coupling and increase code reuse, but improper use often leads to unmaintainable, tangled code. Here's a typical bad use of dependency injection, where a service class directly instantiates too many dependencies, causing tight coupling and making testing hard. This design fails because the class has direct dependencies on concrete implementations, leading to tight coupling. Changes in logger or database force changes here, increasing maintenance cost and reducing flexibility. Refactoring by injecting dependencies via the constructor decouples the service from concrete classes, promoting easier testing and flexibility in swapping implementations. Constructor injection reduces coupling by externalizing dependencies, enabling easier unit testing and better separation of concerns between components. Using interfaces for dependencies further abstracts implementations, making your code resilient to changes and easier to mock in tests. Always follow these rules to keep DI maintainable. One responsibility per class, keep interfaces small and focused, and prefer composition over inheritance for flexibility. Ignoring proper dependency injection increases maintenance risk drastically, leading to fragile code that's hard to modify or test, causing downtime and developer frustration. Over-injecting dependencies can also backfire by increasing complexity and creating dependency bloat, making the code hard to understand and maintain. Group related dependencies into cohesive services to reduce injection points and improve clarity, avoiding excessive constructor parameters. This grouping reduces dependency surface and improves encapsulation, making the code easier to reason about and evolve over time. Use factories or providers when dependencies require complex setup, keeping your classes focused on behavior rather than construction. Remember these practical tips: limit constructor parameters, inject abstractions, not implementations, and delegate creation to factories or DI containers. Skipping abstraction layers in DI or ignoring composition patterns can increase maintenance risk and technical debt, slowing down feature delivery. Avoid using DI to inject business logic or state management directly, as this creates hidden dependencies and breaks encapsulation. Separate concerns by extracting business rules into dedicated services, injected as abstractions, ensuring clear boundaries and maintainability. Clear separation of concerns allows for replaceable components and easier testing, reducing coupling between layers and improving maintainability. Use dependency injection containers carefully to manage lifecycle and scope, avoiding global state and hidden side effects. Apply these rules. Keep DI explicit, avoid service locators, inject abstractions, and keep your DI container configuration simple and transparent. Overcomplicated DI or ignoring best practices results in maintenance risk that leads to bugs, slow onboarding, and costly refactors. Proper dependency injection supports inversion of control and loose coupling, critical for scalable and maintainable codebases. Final example shows clean DI with interfaces, constructor injection, and separated concerns, enabling easy testing and future changes. Remember, name each responsibility clearly, hide what changes behind abstractions, and compose behavior with clean dependencies for maintainable code.